Welcome participants. This is Professor G. Shastry from Department of Mechanical Engineering. Today I will be discussing about the mechanical engineering with specialization in production engineering. So in this webcast I will be uh, telling you about the course and the structure and the state of facilities in form of labs that are available, benefits, and some of the career opportunities that are existing for this particular course. So let us start with the first slide, that is what is a mechanical engineering basically. As you are aware, it is one of the largest and the broadest and the oldest engineering disciplines of engineering. Is one of the oldest, you can say it is a type of a system which is normally used to drive technologies and the industries, and it is going to covers different areas like energy, design, manufacturing, mechatronics, robotics, mechanics, materials, and etc. So it is a very widespread what you call discipline, and production engineering is a allied what you call area of mechanical engineering. As already I have told you that it has encompasses so many disciplines. It's a combination of manufacturing and management science. So its basic focus will be on the different manufacturing technologies, and also its management, what you call related what you call controls to it. Production basically starts with raw material and ends with finished product. So in between, whatever the planning activities that exist, right from raw material, procurement of raw material, okay, and then planning the transformation of the manufacturing processes at different particular stages, and then converting into a final product. All this, what you call conversion or the transformation technologies, it comes under this production engineering. In another simple term, you can say that it is the integration of people, material, and energy in a productive way. So, why we going for the production engineering? The reason is we want to improve the productivity of an industry, and productivity basically focuses with the utilization of material, utilization of manpower, utilization of machines, and the utilization of the investment that is being made. So all these six areas gets integrated. In the process, we go with the design, development. We understand how to make the design, how to go for the development of a system or implementation. What are the various operational what you call issues, maintenance, and control of the different processes that are involved in the product manufacturing. Also, this particular course, it may include material research to machinery development, like we use some other techniques, okay, like CAD CAM, FMS, computer integrated manufacturing, automation, and some interrelated technologies by which we can make the manufacturing process fast, reliable, and effective. So it all comes under the manufacturing, where these are the areas which we will be going with production engineering. Now you can see in the slide the specialized what you call the area where you will be, where the production engineering or its allied what you call management principles are being focused. Left side you can see the input, on the right side you can see the output. Left side for an input you have material, labor, equipment, capital, and in between you can see the different technologies that come into picture, and on the right side you can see it's the output, and from the output it goes to the market. Now in between you can see there are different technologies like forecast, because whenever we go in for any manufacturing activity we need to understand its its usage or its demand in the market. Then we need to understand its the plant, whatever the industry layout is, how the location of the industry is, how the layout is. Then we will be going with the design, what should be the design of the product, and how we analyze the product, how to optimize the product, how to synthesize the product. Once we are very clear with that particular product finalization, then we go in for the manufacturing. Because in this particular product, there different things are going to come again, like you will be selecting the different techniques like related to CAD CAM, computer, you will be doing some analysis, you will be thinking about some automation that should be included in the design, all those things. Then we will be going in for the real manufacturing part, where we will be going with the planning part, where we will be planning the production, which particular machine to be used, for how much time it should be used, and who are the persons who are specialized to do the operations. All these things will be planned. Same time we will be seeing the material requirement, we will be going with from where the material procurement can be done, what should be the quality of the material, and then we will be going with the capacity planning, that means the resources that are available with us. The resources include your machine, include your manpower, include other what you call related utilities, auxiliary what you call uh, uh, related what you call aspects. We will take all this, we'll plan it, we'll try and study this particular areas very extensively, and then over and above, for doing all this particular activity we need to have some control, and those particular control can be linked with mechatronic systems, automation systems, because everything cannot be conventional, because nowadays almost every manufacturing process or every manufacturing system is integrated with automatic systems in form of, it could be electronic technology or mechatronics controls, or we can go in for some programming, we can go in for CNC, or we can have some open closed loop feedback system and all those things. So that the central part what we are talking of is the one where it is going to have a complete what you call control on the quality, on the effective manufacturing part of it. Then once we manufacture it, then the next part comes is quality control and inventory control, where we measure, we try and see the quality management, what is the quality engineering that is involved in this particular product manufacturing, and then what are its specifications, are the specifications conformed to the design, the design whatever it is being done, all this, that those things will be covered. And of course the inventory, that is again the management related. Why? Because we don't want the industry, we don't want the system to have excess of material, excess of finished goods, we don't want to have excess of the facilities which becomes redundant in the system. So this is where what the specialization area that we are going to cover up, along with the mechanical, the core mechanical part. This course includes, it imparts, okay, knowledge starting with the basic science and engineering subjects, like starts with mathematics, engineering physics, okay, engineering chemistry, then maybe bit of, okay, communication and all those things. Then it covers with the fundamental mechanical engineering subjects, starting with a very basic thing, basic course, that is the engineering mechanics. Then the fundamentals of other engineerings like electrical engineering, electronics engineering. Then the language of engineers, that is the engineering drawing, because that is very important for mechanical engineering. Those things will be covered under the fundamentals of mechanical engineering. Then, then the third part that will be getting covered is the material selections. Then we'll see how to go in for the design of different components that are being used in the mechanical systems, like design for shaft, design for bolt, design for nut, design for springs, design for keys, design for pins. Likewise, every simple element, okay, the considerations and the methods that are to be used for designing will be covered, okay, under this particular course. Then we are going to have some softwares through which the modeling part can be done, because conventionally doing it may take time. So we have some software platforms using which the softwares can be helpful for generating the model and seeing the manufacturing, okay, in form of a simulation on a virtual platform. Then we will be covering some of the specialized skill sets in production and industrial engineering. As I told you, we'll be covering about, the shop layout or the plant layout. Then we will be discussing about the work study, production, planning, control, and all such what you call related, what you call technologies which will improve the efficiency, improve the productivity of the system. Then we have some specialized what you call courses which take you to the design of tool, design of die, and design of manufacturing systems, quality, and because everything we need to do, okay, with optimization of the cost. So a bit of cost control and cost control techniques. Like for example, work holding devices for a typical shapes. So we will be trying to design or optimize a work holding device so that the time it takes to hold a typical shaped component becomes less. Then for doing a manufacturing, we'll be developing a program so that those program can be simulated and then straight away it can be brought to manufacturing system on the machine. So that is how the course that is going to get imparted. Then a bit of information on the course structure. We start with, as already I communicated, it will start with the basic science. So these are the courses which will be covered under the basic sciences in first year and the second year. So I start with English communication, environmental studies, which is very important, because any industry, for any particular industry, the most important part is the industry should have the clearance of environment. So environment studies becomes a very important part. Then mathematics. Why? Because every design, every application, every modeling part requires engineering, okay, mathematical background, physics, okay, and chemistry. Then we have general engineering. As already told you, we start with basic electrical electronics. We cover the fundamentals of basic electrical and electronics. Computer programming, because nowadays we require C, C++, okay, as the basic tool for doing the programming. Then the language of engineers, engineering graphics, mechanics. Then the workshop technology, which gives you a what you call ready hand information about the tools that are being used, okay, for the initial what you call development of manufacturing systems. The lab related to it, and the labs related to this electrical and electronics. Now, then the second year we cover with some core mechanical engineering courses like engineering thermodynamics, which will deal with no, the heat, work, internal energies, steady flow energy equations, boilers. Okay, whatever those things so will be covered in the engineering thermodynamics. Then the fluid mechanics. So fluid mechanics basically deals with okay the fluid what you call dynamics, the fluid properties. Okay, what is the how we, because in almost in any particular system we require okay the fluid like in machines you may require oil. So for an oil you need to understand what is the flow rate of an oil. Such things, I think such applications will be covered under fluid mechanics. Then the drawing becomes another important element as a part of core mechanical engineering. Then manufacturing technology, material science, measurement, metrology, and the strength of materials. All this comes under the core of mechanical engineering. So we will understand the basic what are the different types of materials, what should be the properties of material, what is an hardness, what is the toughness, okay, what are the various manufacturing process, what should be the material properties that should be emerged after the manufacturing process is done, what are the various okay measurement techniques that needs to be used for doing the quality check, that is metrology, and what should be the strength of material, okay, what should be the stress strain, all these things will be covered under this in the second year under the core mechanical engineering. And further adding to this we'll be studying about the theory of machines, thermal engineering. Theory of machines deals with the velocity and velocity what we call diagram, that means the velocity and acceleration part of okay the machines when they are subjected to working, governors which are being used in automobiles, flywheels which are used for storing the energy, gears which are being used for power transmission. All these things will be covered under the theory of machines. Thermal engineering, where we will be covering where the different it will be covering the boilers, different types of boilers, then the compressors, refrigerators, air conditioners, such things will be covered under the thermal engineering. Then we have heat transfer. Heat transfer basically deals with okay the conduction, convection, radiation, because heat transfer becomes another important component of mechanical engineering. Then we'll be discuss then the manufacturing technology, where the different types of machines, CNC machines, conventional machines will be covered. Then the operation research, which basically deals with is a tool which is helps you making a decision, because engineering is a very complex vertical area where the different, because of different complexities the making decision is always going to be a critical parameter. So operation research is a tool which will help to take good decisions. Now, this specialization part, that is the production engineering domain, where we'll be touching those particular aspects in second year, third year, and final year also. Starting with the manufacturing process, that is in addition to mechanical, what already I have discussed. Second year will be very extensive on manufacturing process. So you'll be given the idea on the different manufacturing process that are available like casting, casting, metal forming, welding, okay, powder metallurgy. There are different methods. Then the machine drawing labs. What are the in machine drawing lab will, because as already told you the drawing is a it is a tool to be understood by okay every engineer, because that is a mode of communication. So the assembly drawings, machine drawing, the component drawing, the conventions that need to be used in engineering drawings, everything will be covered under that machine drawing. Then in the third year, then we'll be discussing about the under the domain the manufacturing technology. This manufacturing technology basically it covers the conventional machines and the CNC machines. Conventional machines, the mechanics of its working, what are the forces and how these particular forces affects the machinability of a particular material, what are the various operations that can be performed on each individual machine, those things will be covered. And then the industrial engineering, where the complete what you call the productivity of an industry is going to depend, where we'll be studying about the work study, the location, the layout of the machines, the movement of the manpower, the raw materials, the stackage of raw material, and where we keep the semi-finished goods, where to keep the finished goods, how to go for the material handling system, where the material handling system should be placed. All such things will be okay under the cover of industrial engineering. Then the CAD CAM, it is a tool which will help in to develop the model and to go in for the analysis bit faster, because conventionally it takes a lot of time. So we have different technologies like CAD CAM is one, where the designing and the modeling can be done, and the analysis optimization can be done on a common platform. Then it can be integrated with CAD CAM. And then the major project which is in the final year, then that will be basically focused on the production engineering domain, that is the specialization which is being offered. Then as a part of the mechanical engineering with specialization, there are certain electives what we have just covered almost everything. So under that, in the third year in this particular domain, there are set of electives to be opted. First elective in the third year, it could be material and operations management, where we can see the complete what we call functioning of an industry. Okay, as far as the management operation part is concerned and the material and procurement part is concerned. Then there are three electives. One is reverse engineering, product design and development. Under the second elective, we have industrial automation and robotics, where we see the different what we call the tools which are being used for the control, for material handling, for the faster what we call process manufacturing. Then the metal cutting and tool design, where the design of the tool, the metal cutting principle, that means how much should be the cutting force for a particular material, and what should be the nomenclature of the tool, and how it should be used. All these things will be covered there. Then in elective 3, again we will be studying on three different electives, out of which you may have to opt one. One is the work study and ergonomics. As you are aware, ergonomics means how fast you can do the work, okay, without changing your body movements, or without going for excess what you call movement of the hand and limbs. Then the quality control, again this is industrial quality control. Normally it is also called an inspection department in the industry. The different tools that are being used for the quality control. Then the design considerations, the principle and design consideration of metal forming, because metal forming, it's again all the detailed what you call the analysis and design of metal forming operation will be covered under this particular elective. Then the elective 4 and 5 in the final year will be offered, which will basically it will be covering the what you call the production management part, where the economics, that is the cost, the quality management, the supply chain management, So all the management, the operational management and operational issues will be discussed in these two electives that will be offered in fourth year and fifth year. Sorry, fourth and fifth electives. That is third year, final year. Now these are some of the laboratories where the experiments can be performed. There's a few laboratories are being covered up here. You can see the on the top left, on the top what you call left side, you can see the machine shop, and which have got lathe machines, and the bottom you can see the shaper, and on the right you can see the milling machine, then the profile projector which is used for doing the measurement and inspection related activities. So these are some of the laboratories which will be used as a part of machine shop or manufacturing technology and metrology lab. Then we have the foundry section and the fitting section, which is comes under the manufacturing process. I think it will under the fitting. I think the basic what you call tools, the understanding of basic tools that should be used in the workshop. Okay, in the very first year engineering, those things will be you will be exposed of. Then the foundry, where the different tools that are used in foundries, how to prepare a mold, how to do the casting operation. I think these are one of the laboratories which will be there. Then the next slide gives you the metal forming operations, where we normally go for the blacksmithy operations, where the metal forming is going to take place. So the we have the furnace, you can see the hammers, the swage block where the metal is heated and then it been struck by an hammer so that the transformation of the material is going to take place. So the different shapes that are required for all the engineering applications will be covered under that particular uh, lab. Then we have the CAM lab, which is being used for the manufacturing. That is the CNC machine. So the conventional machines already have seen as a part of machine shop. This is a laboratory where the machines are being operated by using the computer controls. So that is a lathe machine. That is a CNC lathe machine, which is which can be operated by giving some program of instructions. Model can be generated in CAD, and then the manufacturing operation can be done by using these particular machines by using the program of instructions through a particular set of control systems. The next slide is about the IC engines lab, where the different engines on which we are going to perform some experiments, calculating the efficiency of an engine on petrol, on diesel, understanding the basic nomenclature of an engine, what is a cylinder, what is a piston, what is a connecting rod. The nomenclature will be understood, and then the working can be understood, then the efficiency of the engine can be calculated. Then the computer control machining, where we use the machining operation by using the interference of the computer through again set of instructions by means of a program. The next part is the material testing laboratory, where the laboratory material testing is being done. That means the dynamic behavior of the material, what will be the maximum strength the material can sustain under particular load, and how the material is going to behave under different loading conditions. So we have different types of tests. different properties can be computed, like toughness, hardness, then its impact strength, then tensile strength, compressive strength, bending strength. So that means every property that is required in any form of application for a particular given material can be tested in this material testing laboratory. Then next is a fluid mechanics laboratory, where the flow of fluid, what is the friction that is what is the friction that normally it comes encounters when the fluid is flowing through a pipe. Then you will be doing some experiments on turbines, okay, for the which is being used for power generation, and how much will be power that will be getting produced, and all such things will be the information and the exposure will be there in fluid mechanics and machinery lab. Then we have the mechatronics lab, where you will be coming across the different controls. There is a center of excellence from Bosch, that we call it as a Bosch Center of Excellence. So there are different systems related to programming, PLCs, that is program logic controllers, hydraulic and pneumatic equipments. These are all hand-on equipments where all the experiments, all the testing, and all the okay properties can be very well, it can be evaluated, okay, by using these particular setups. So for a particular load, what will be, should be the hydraulic pressure, what should be the pneumatic pressure, this all these things can be, okay, it can be very well, it can be demonstrated, and it can be understood very practically. Just like when we play toys, with the toys, when you build up blocks with a toy, similar to that is this particular laboratory, which will give you hands-on experience about its design and its capabilities. Then the application areas for this mechanical engineering with specialization production engineering, it's very wide. It has got a very wide range of what you call areas where it can be applied. One is the food and beverages, food, food processing industries, locomotives, then automotives, automotive industries, because manufacturing will be there almost everywhere. You have industrial manufacturing, that may be a fabrication shop, or maybe a workshop, or maybe a steel industry, or maybe a power industry. Okay, everywhere we have this industrial manufacturing. Then we have paper and pulp products. That means in paper manufacturing industry, because almost everywhere we have the mechanical system running. So paper and manufacturing industry, we are going to have construction industries, electronics industries, aerospace, defense. Almost these are all the application areas where the the production engineering concepts related to mechanical engineering can be, okay, very well, it can be applied, because everywhere productivity matters, and productivity becomes a very key term for the success of any industry. These are some more what you call the applied areas. Heavy industries, then automotive industries, there are some more application areas. Then in gear manufacturing industries, then any specialized what you call robot manufacturing industries, because wherever there is a fabrication, or wherever there are elements of material and different stages of manufacturing are concerned, there the production and industrial engineering, okay, background will always be a supplement to the industry. Now coming to the benefits, once this particular course is done, then normally the proficiency we may go in the areas of methods engineering, work measurement. Methods engineering means the improvement of yes. Methods engineering means the improvement of the existing methods, simplifying the what you call the type of system that is existing. Then the plant layout, designing the plant layout, material handling system. Then operations management. That means you will be dealing with material requirement planning, manufacturing planning, then aggregate planning, production planning. All these things are going to come. Then the project management, a big project when it's taken, okay, different activities that are involved in a project, those things, everything can be taken care of. Then inventory already I covered. Then quality control, which is again a very important what you call aspect for the success of any industry. The quality control of an individual component, quality control of an assembly. Then the total quality management, that means the quality consciousness in an industry. Then supply chain management, lean manufacturing, these are all the tools which are used to improve the productivity and reduce the wastage in an industry. Then the manufacturing, production, distribution, ergonomics, then the process improvement, then bit of what you call knowledge on personal management, financial management, sales, service, etc. Then normally when a mechanical engineering with will always have a benefit in this particular industries in form of the cadres like automotive and aerospace can work as production engineer or a maintenance engineer in automotive sectors. In construction companies, they can go as a maintenance engineer. In design, utility companies, steel foundry, steel industries, foundries, etc., such related companies, one can go as a planning engineer, methods engineer, go as a production engineer, can go as a maintenance engineer, or can go as a quality engineer also. In, of course, academia is very well okay, it has got the option of teaching. In food processing industries, garment industry, garment manufacturing industries, the focused area could be production and planning engineer. You can go as a planning engineer, you can go as a quality control engineer, you can go as a maintenance engineer. And pharmaceutical industries, paper and pulp industries, methods, one can go as a methods engineer, maintenance engineer. Then plenty of options are always there for a production engineer, because any industry, it requires a mechanical engineer, and it requires a production engineer, it requires the expertise of okay the of that particular engineering discipline, which can directly reflect on the productivity of the organization. So that's all. Thank you very much. Any queries, any questions, it will be answered. Yes, Mr. Siddharth Manchanda. Your question is mechatronics is part of mechanical engineering. See, mechatronics is the is the combination of okay, mechanical, electronics, information technology, and electrical engineering. So it is an integration of all the technologies. It is basically a system which is being used to run a mechanical system ultimately. So when you say that it is a part of a mechanical system, yes, partly it's a part of mechanical system. Wherever the mechanical part is there, that becomes a part of it. But it is an integration of different technologies. Okay, thank you very much.